This is a walkthrough of the Further Maths AS Paper 1, which is Core Pure Maths. Question number 1. The matrices P and Q represent linear transformations P and Q respectively of the plane. And here's the matrices P and Q here. Let's just highlight those. So P is this half, and then we've got 1 root 3, negative root 3, 1, and Q is this negative 1, 0, 0, 1. The linear transformation M is formed by first applying P, so we first apply P and then apply Q. Part A, find the matrix M that represents the linear transformation M. Now the important thing with this is that when you apply transformations, you start from the left and you work your way to the you start from the right and work your way to the left. So the first transformation is always going to be written over this way. The last transformation is going to be written this way. So even though P goes first, we write down QP like this. Right, so let's multiply those two matrices together. So we've got negative 1, 0, 0, 1, and that's times by P, which is a half, 1, root 3, negative root 3, 1. Okay, I want to get rid of that half, so I'll stick that into the P matrix. So I have negative 1, 0, 0, 1, and then if I divide every element by 2, I get a half, root 3 over 2, negative root 3 over 2 and a half. Okay, so let's multiply these out. So first row, first column, negative 1 times by a half plus 0 times by negative root 3 over 2 is just going to be a negative half. All right, first row, second column. So negative 1 times by root 3 over 2 plus 0 times by a half just leaves us with negative root 3 over 2. Oops. And then the bottom row, 0 times by a half, and first column, plus 1 times by negative root 3 over 2 is negative root 3 over 2. Then the last one is 0 times by root 3 over 2 plus 1 times a half, which is just a half. Okay, so there we go. There's our matrix that represents the transformation P first, followed by Q. Part B. So part B says, show that the invariant points of the linear transformation M, so invariant points are points which don't move. They keep the same position under a transformation. And what we need to do is to show they form a line in the plane, stating the equation of this line. So what does that mean, invariant points? That means when I apply the transformation M to a general set of points, I'll just call them XY, they are going to remain as XY. So let's set this up and see what we get. So M is negative a half, negative root 3 over 2, negative root 3 over 2, a half, and that's going to get times by the point, general points XY, and that will leave me with XY. Right, let's multiply this out and see what we get. So I'll get negative a half X, minus root 3 over 2Y, minus root 3 over 2Y is equal to X. That's what I get on the top row. Bottom row, we do the same thing. So negative root 3 over 2 times by X, so negative root 3 over 2X, then plus a half Y, is equal to Y. Now let's see which or what each row gives us. So if I look at the top row, I want to rearrange it to make X the subject. So if I add a half X to both sides, I'll get negative root 3 over 2Y is equal to, so this will be X plus a half of X, so that's 3 over 2X. I'll times both sides by 2, so I'll get negative root 3Y is equal to 3X, and then I'll divide both sides by negative root 3 and I'll get Y is equal to negative 3 over root 3X. I'll do the same with the bottom row here. Now if I've got the invariant point, then the second equation that I form should be the first. It's the same as the first, or equivalent to the first. So the second row, I have this half y. So what I'll do is I'll move the y over to this side. Oh, actually, no, take away half y from both sides. So I'll basically have half y is equal to negative root 3 over 2x. Just like the last one, I'll times both sides by 2. So I'll get y is equal to negative root 3x. Now these two equations are actually the same, because this part here, the 3 over root 3, is the same as root 3. Let me show you, just to prove it to you. So if I've got 3 over root 3, I rationalise the denominator, times the top and the bottom by root 3, I'll end up with 3 root 3 over 3. The 3's cancel out, you're just left with root 3. So these two things here are the same. I've got the same equation from both rows of the information that I got by multiplying out these matrices. So the invariant line, we can write down this equation now, is, now we can write either one of these two down. I'll use the one where the denominator has been rationalized. Y is equal to negative root 3x. Let's just highlight that. Question 2. Sketch on an arcane diagram the set of points x where z is a complex number. We've got a modulus of z minus 4 minus 2i is less than 3, and the intersect of that, and an argument which goes between 0 and pi over 4. And it says on our diagram, we need to shade the part of the diagram that is included in the set, use solid lines to show the parts of the boundary that are included in the set, and use dashed lines to show parts of the boundary that are not included in the set. So let's start by drawing some axes. Okay, now when you draw these types of things, you want to try and be as accurate as you can. So, use a ruler for any lines, use a compass for any circles that you have. And we've got a circle here. So this is going to be a circle. Now what I want to do is write it in the correct form so I can see where the centre of the circle is. So it'd be z minus, and in brackets 4 plus 2i. So that gives the centre of the circle as 4, 2. I'll mark that on my diagram, 4, 2 there. And the radius is 3, so I'm just going to mark where the edges of that circle will be, and I'll mark them with some green crosses. Right, so a radius of 3, that means that on this side the circle is going to cross at this point, and on the other side 4 plus 3 is 7, so that means the other side is going to be there. Now where's the top of the circle going to be? It'll be at 5, 3 above 2, and then at negative 1 down here. Okay, now this is less than 3, so that means when I draw this circle I need to draw it with a dotted line like this. So you don't draw a solid line. That might be a bit difficult if you're using a compass. I guess you could draw the circle and then go around and rub those things out. So that's my first one drawn. The second one is a half line. Now just because this is arc z, it's a half line that starts at the origin. Okay, so it's going to start here. Let me draw my half line in purple. So I'll have a circle there, and it's going between and including 0 and pi over 4. Now pi over 4 is the same as 45 degrees, so that means my half line is going to be at the bottom. Now this is going to be a solid line. Okay, so there's a solid purple line down here, and then another solid line at 45 degrees. And because I've sort of done this on a nice scale, I know that it's going to be going through like 2, 2, 4, 4, 6, 6, 8, 8, and so on. So that allows me to get a fairly accurate representation of that half line and circle. Now I need to shade in the overlap of both of these, and that's going to be this bit in here where they both overlap. So let's highlight that in yellow. So shade that in yellow. Hopefully you can see that. So this is the region X, and let's call it X here. That's what they want. Part B, what we need to do is show that the complex number z equals 5 plus 4i is in the set X, so it's somewhere in this region here. That basically means if I replace z in both of these loci here into here, and it satisfies it, then I know, or satisfies both, I know it's in a region. So we take the circle, okay, and we replace z with 5 plus 4i. So I'm going to have 5 plus 4i, that's where z was, minus 4 minus 2i, and I'm going to work out the modulus of that, the size of that, and if it's less than 3, I know it's in the circle, and we've half answered the question. So what we got the modulus of, so we got 5 minus 4, which is 1, and then 4i minus 2i, which is just 2i. Right, so we want to work out the modulus of that, the size of that, which basically means we're going to do the square root of 1 squared plus 2 squared. So that's root 5. Let's see what that is. And that is 2.236 and so on. Now that is less than 3, so we can say therefore z is in this part of the set. I'll put that z, or z satisfies this. Z minus 4 minus 2i is less than 3. Okay, it also needs to satisfy the argument part as well. Okay, so what we're going to do now is we're going to work out the argument of z. Now whenever I work out arguments, I just draw like a little sketch so I know that I'm working out the right angles. We've got our real and imaginary axis here, and it's 5 across, 4 up, so we're looking at something like this. So this is going to be the argument here, okay, and to find that I'm going to do the tan inverse of 4 over 5. So the argument of z is the tan inverse, or arctan 4 over 5, opposite over adjacent, and making sure that your calculator is in radians, that's 0.6747. Okay, how does that compare to, well, it's definitely greater than 0, yeah, so 0.6747, it's greater than 0, or greater than or equal to 0. Right, now is it less than or equal to pi over 4? I guess one way to do that is actually to work out what pi over 4 is as a decimal. That's 0.785 something. Okay, so it's less than or equal to pi over 4. So I'll just put in brackets here that pi over 4 is 0.7853, so there's no ambiguity here. So it satisfies the second one. So z also satisfies its argument being between 0 and pi over 4, and then we can finish off by saying therefore z is in the set X. Question 3. Part A. Find in terms of the real constant k the determinant of this matrix here M, which is 3, 2, 1, 2, 3, negative 1, 1, k, 2. Okay, so determinant of M is equal to, so we start with the first element and then write down its minor, so it's going to be 3 times by 3 negative 1 k2, not k plus 2, just k2, Then the next one here is 2, so it's going to be minus 2, and its minor is going to be 2, negative 1, 1, 2, and then plus 1, and its minor is 2, 3, 1, k. Let's now work out what this gives us. So we will get 3 times by 6 minus negative k, minus 2 times by 4 minus negative 1, and then plus 1 times by 2k minus 3. Right. Simplifying that, we'll get 3 and then 6 plus k, minus 2 times by 5, and then plus 2k minus 3. That all simplified will give us, so you've got 3k here, 2k here, so it's 5k, and then we'll have 18 minus 10, which is going to be 8, and then 8 minus 3 is 5, so 5k plus 5 is the determinant of this matrix M. Moving on, 3 distinct planes, pi 1, pi 2, pi 3, are defined by 3 equations. Pi 1 is r dot 321 is equal to 4. Plane number 2, pi 2, is r is equal to 1, 2, 3, plus lambda 1, negative 1, negative 1, plus mu 1, 0, 2. Plane number 3 is given by x plus ky plus 2z is equal to negative 1, where lambda and mu are scalars. Part B, there's 2 parts to part B. First part of part B, we need to find a Cartesian equation for, first of all, plane number 1, pi 1, and then we'll move on and we'll do plane number 2. So the first thing we're going to do with the first plane here is we'll replace r with x, y, z, so a Cartesian point in the plane rather than a vector point in the plane. Dot 3, 2, 1 is equal to 4. So on the left hand side we'll do the dot product, so 3x plus 2y plus z is equal to 4. There we go, we've got the Cartesian equation, so there wasn't much work to do there. Second one is going to be a little bit more work to find the Cartesian equation for the second plane, pi 2. So just like before, we'll replace this vector point with a Cartesian point r, so that gets replaced with x, y, z. Then on the other side, I'm just going to gather together all of these terms and put them into one bracket. So I will have 1 plus lambda plus mu. Yeah, so 1 plus lambda plus mu. Then in the second row here, I will have 2 minus lambda, just 2 minus lambda. And then in the bottom row here, that will give me 3 minus lambda plus 2 mu. Now what I can do now is to say that x is equal to 1 plus lambda plus mu, y is equal to 2 minus lambda, and z is equal to 3 minus lambda plus 2 mu. So what I need to do is to eliminate mu and lambda. So I'm going to start by taking this this equation here, the one for y, and rearranging it to make lambda the subject. So taking that, I will get lambda is equal to 2 minus y. Now what I'm going to do is to substitute that into this equation here for x, and that will get rid of lambda and replace it with 2 minus y. So what I'll get is x is equal to 1 plus 2 minus y plus mu. Now I'll just tidy it up a bit, and I'll get mu is equal to x plus y minus 3. Now the reason I've made mu the subject is because then it allows me to substitute that into the third equation for z. We need to use all 3 equations. So lambda in here is going to get replaced with 2 minus y. Mu here is going to get replaced with x plus y minus 3. So let's do that and see what we'll get. So we'll get z is equal to 3 minus lambda, so that's minus 2 minus y, and then plus 2 mu, and that's x plus y minus 3. If I expand the brackets and simplify that out, I'll get z is equal to 1 plus y plus 2x plus 2y minus 6, and getting it in the correct form for a Cartesian, and we want that in the form ax plus by plus cz is equal to d, or minus d is equal to 0. And if I do that, I'll get 2x plus 3y minus z is equal to 5. So there we go. That is the Cartesian plane, Cartesian equation of that plane pi2. Okay, given that the three planes pi1, pi2 and pi3 form a sheaf, part C, use the answer to part A to explain why k is equal to -1. So first of all, if I look at the Cartesian equation of all three of these planes, what you'll notice is that the coefficients of x, y and z are actually the elements in this matrix: 3, 2, 1, 3, 2, 1, 2, 3, -1, 2, 3, -1, and 1, k2, 1, k2. So if I want to solve this system of equations, pi1, pi2 and pi3, I actually need to solve this 3, 2, 1, 2, 3, -1, 1, k2, which is the matrix M, times by x, y, z is equal to the numbers we have on the other side, 4, 5, -1. So now I've written this system of equations, the solutions to these, in matrix form. Now I know if I was going to solve this, I would multiply each side on the left hand side by the inverse of m. Now we know that if the determinant of m is not equal to 0, then there is a unique solution. That means that all the planes meet at the point. Now, since we're told that the planes form a sheaf, there is no unique solution, which must mean that the determinant of this matrix M is equal to 0. Now, we worked out the determinant of M in part A, and that means that the determinant of M is equal to 0, which then means that 5k plus 5 is equal to 0, because that's the determinant of M. That will give us 5k is equal to -5, which then shows that k is equal to -1. Question 4. A company manufacturing radios agreed a 20-year contract with a retailer to supply its radios. In the first year of the contract, 500 radios were supplied to the retailer. In each subsequent year, the number of radios supplied to the retailer was 50 more than in the previous year. The amount received by the company for each radio during year N of the contract was 20 plus N squared over 45 pounds. The total cost of producing the radios during year N was modelled as 1000 plus 10N squared. Part A. Show that, according to the model, the profit made by the company in year N in pounds, and it's P sub N, is given by P sub N is equal to 10 over 9 times by N cubed plus 900N plus 7,200. Now, the first thing to note is, how are we going to make this profit? What's the profit made up of? Well, it's made up of the number of radios made times by the profit per radio, and then you subtract your costs. Okay, so let's start with the number of radios made. Now, we're told that we start with 500 radios, and then in each year after that it increases by 50. So 500 in the first year, then 550 in the second year, 600 in the third year, and so on. So the way I'm going to express that is by doing 500 plus n minus 1 times by 50. In other words, in year 1 it's just going to be 500 because you have 1 minus 1. In year 2 I'll get the 550. So that seems to give me an expression in terms of n, and n is going to be the number of years starting from 0, so I might write that down. So n, not starting from 0, starting from 1, so 1, 2, and so on, up to year 20. And that needs to be multiplied by the profit made per radio, and that's going to be this expression here. So let's times that by 20 plus n squared over 45. And then I need to subtract from that my costs, and they're modelled as 1000 plus 10n squared. So let's start to simplify this. So let's start with this here. So I'll have 500, and then when I multiply this out, I'll have 50n minus 50. So 500 minus 50, that's 450. And then plus 50n. And I want to multiply that by 20 plus n squared over 45, and then subtract this 1000 plus 10n squared. So multiplying that, those first sets of brackets, 450 times by 20 is going to be 9000. Then 450 times by n squared over 45, that gives 10n squared. Then we have 50n times by 20, that's 1000n. And then lastly 50n times by n squared over 45, that gives 10 over 9 n cubed. Right, so that's the first part. And then from that we're going to subtract 1000 plus 10n squared. So let's do that and then see what we get. And we'll put this polynomial in order of size. So 10 over 9n cubed would be the first term. Then I've got 10n squared, then minus 10n squared, so that cancels out. So there's going to be no n squared terms. Then I'm going to have, in terms of n, just 1000n, so plus 1000n. So I've dealt with that term. And then I'll have 9000 minus 1000, so that'll be 8000, so plus 8000. So we need to get it into this form here to get our profit. So that means taking out the 10 over 9 as a factor. So that will give us n cubed. Now I need to work out that if I take 10 over 9 out of the n, in other words, 1000 divided by 10 over 9, that's 900. So 900n. And then do the same thing with this, 8000. Let's do that, 8000 divided by 10 over 9, and that's 7200. So we've got the expression they want as required. Part B. Using the standard results for summations, or use the standard results for summations to show that the total profit made by the company in the first n years of the contract Tn is given by Tn is equal to An times by n cubed plus Bn squared plus Cn plus D, where A, B, C and D are constants to be found. So let's get rid of this here, so give myself some space to write my working. Okay, so what I'm going to have to do first of all, let's take this 10 over 9 and put that in front of any summations that I write down. And the first one is going to be the sum of all these n cubed. So I'll write down, so the sum of n cubed. And I'm going from year 1 to year n. So r equals 1 to big N. Then I want the sum of all these 900 n's. So that's going to be plus 900 times the sum of these n's from r equals 1 to n. And then lastly, the 7,200. So plus 7,200 times the sum of 1s from r equals 1 to big N. So I'm going to be using these summations here. Now the one in red is normally in the formula book. So the sum of r cubed, and then the sum of r, this one you need to know, basically the sum of natural numbers. Right, let's write down what this gives us then. So this sum is going to be equal to 10 over 9. And then we've got this sum of r cubed, or n cubed, from r equals 1 here to big N. And that's this one up here, not the bottom one. So that will be a quarter big N squared times by big N plus 1 all squared. Then we're going to have 900 times by our sum of n. So that's going to be this one. So the 900 is going to get times by half big N, n plus 1, just about squeeze it in. And then the sum of 7,200 ones from 1 to n will be 7,200 big N. So I've expanded the brackets. I'm not going to talk through all of it, but this is what we get when we expand the brackets and simplify it a bit. I'm going to simplify it a bit further now. And keeping an eye on the answer here, I want to take n out. So I'm going to take n out of every term as well and simplify this further. So now I've got this here. Keeping an eye on the answer, I notice that not only is there n taken out, but the coefficient of the n cubed term needs to be 1. So I need to take that quarter out. So in fact, outside of the brackets, I'll have 10n over 9 times 4, 36. And then inside the bracket, I will have n cubed plus 2n squared plus n, and then the 450 is going to become 1,800n, and then the 7,650, if I times that by 4, that'd be 30,600. So I think we're almost there. So we can simplify this, the 10 over 36 to 5 over 18n. So those are my value of a. Inside the brackets, n cubed plus 2n squared, and then the n plus the 1800n, that's 1801n plus 30,600. Okay, so what have I got from that? A, let's write it up here. A is equal to 5 over 18. B, that's the coefficient of the n squared term, that's 2. C, the coefficient of the n term, 1,801. And D, the number that's on its own, 30,600. Okay, part C, answer highlighted. At the end of the 20 years, the company found that its total profit made from this contract just exceeded basically £500,000. That's not bad. Well, 20 years. Maybe it is bad, I don't know. Assess the model in light of this information. So what I'm going to do in part C is basically substitute 20 into this model here and see how that value compares to the actual profit. So that'll be 5 over 18n, so that's 20, and then times by 20 cubed plus 2 times 20 squared plus 1,801 times by 20 plus 30,600. Now on my calculator, that gives me a value of £419,000. Just one more zero. Right, so the model underestimates the profit. So because I've run out of space, I just put an unhappy face. So the model is not a great model. You could even say by how much it underestimates the profit by what percentage, but that, I would say that's significantly below what the actual profit was. So model's not great, could be improved. Question 5. We have f of z is equal to 8z cubed plus 12z squared plus 6z plus 65. And we're told that given that half minus I root 3 is a root of the equation f of z equals 0, part A, write down the other complex root of the equation. That's nice and straightforward. It's just got to be the conjugate of this. So that's just going to be a half plus I root 3 or root 3i. Part B. Use algebra to solve the equation f of z equals 0 completely. Okay, so let's call the first root that was given alpha, so half minus I root 3. And let's call the second root beta, so it's going to be a half plus I root 3. And we can find the quadratic that has those roots by doing z squared minus the sum of the roots alpha plus beta, z plus the product of the roots alpha times beta. So let's write down what that gives us. So we'll have z squared. Now the sum of the roots, so the imaginary parts cancel out, so just have half plus half, which is 1, so it's going to be minus z, minus 1z. And then to find the product of the roots, the quick way of doing that is going to be the sum of two squares. So that's going to be a half squared. So a half squared, which is a quarter, plus root 3 squared, which is just going to give us 3. So that just becomes z squared minus z plus, and then a quarter plus 3 and a quarter, which is 13 over 4. Now I just want to get rid of the fraction there, so I'm just going to times everything by 4. Not really needed, but it might make the next bit easier. So I have 4z squared minus 4z plus 13. Okay, so let's now find the other factors. So I know f of z can be written as this 4z squared minus 4z plus 13, and this is going to be times by something linear to ensure that I get these terms here. Now, the easiest way is to look at the first and the last term. So first of all, 4z squared times by what is going to give me 8z cubed. That's going to be 2z. It has to be 2z. And then if I look at the last term is going to be given by 13 times by something, and I want 65. So that last term has to be plus 5. Now it's always worth checking that if you expand the brackets you do get this. So let's do that. So I get 4z cubed, then I'll get 20z squared, and then minus 8z squared, so that gives me the 12z squared. Then I will get minus 20z, and then plus 26z, so that gives me the 6z here, and then the 65. So that sort of works out. So to find my other root, I know that then that 2z plus 5, because I'm solving f of z equals 0, 2z plus 5 is equal to 0. So that means that z is equal to, bring the 5 over, minus 5 from both sides, and then divide by 2. So that gives my other root, negative 5 over 2. So let's write them down here, and I'll call those roots alpha, beta, and gamma. So alpha, half minus I root 3. Beta, half plus I root 3. And the other root that I found, let's call that gamma, is going to be negative 5 over 2. Okay, so let's highlight that there. We've done part A. Moving on to part B. Oh, sorry, we have done part B, haven't we? So really, that answer should be written on the line below. Apologies. Okay, all sorted. Now let's move on to part C. Show the roots of f of z on a single Argand diagram. So let me do my Argand diagram over here. So I've got my imaginary and real axis. So I know that I've got a real value of a half here, and then another real value of negative 5 over 2. And I have imaginary values of root 3 and negative root 3, and then I can put the 3 roots on. So let's have our root here, and that is the root beta, a half plus I root 3. We'll have our root over here, which is the conjugate, so that's our root alpha. And then the last root, which is the real root, negative 5 over 2, which is over here, and that's my root gamma. Part D, show that all the roots of f of z form the vertices of an equilateral triangle in the complex plane. Okay, if I'm going to prove that this is an equilateral triangle, I want to show two things. First of all, that all the sides of this equilateral triangle are equal, they're all the same. So let me just sketch in what this equilateral triangle would look like. So I'll just do this. So this bit in green is not part of the Argand diagram, but I want to prove that these three lines are the same length. That doesn't prove that it's equilateral. Actually, I guess it does. But what I want to do, actually, what I'll do as well, is that the angle between adjacent sides is 60 degrees. Angle between adjacent sides is equal to 60 degrees, or pi over 3. Now I guess you could actually do one or the other. Thinking about it, if all sides are the same length, then it must be equilateral. Or if all the angles are 60 degrees, it must be equilateral. I'm going to do both, but I guess you could do one or the other. So let's start with the sides and showing that the sides, those things that I've highlighted in green here, we want to prove that they're all the same length. So let's start by looking at the length of the side between the root alpha and beta. So that's going to be easy enough, because from beta to here is just root 3, and then from here to alpha is going to be root 3. So the length of that side is 2 root 3. Let's move on to another side, and let's look at the length of the side between alpha and gamma. So this is the modulus, the length, the distance between these two vertices alpha and gamma. Now that's going to be equal to the square root of 3 squared plus the square root of 3 squared. So basically the 3 is going to be this distance here between half and negative 5 over 2, and the root 3 is this distance here. So we're basically just using Pythagoras, that squared plus that squared, square rooted. And if we do that, we also get 2 root 3. Now we don't need to do this third one here because this is symmetrical. So we could also say, without doing any working, by symmetry, and we're allowed to do that where there is symmetry, the distance between the root beta and gamma is also equal to 2 root 3. We don't need any working. So that means that all sides are the same length. So we've proved they're all the same length, and I guess from this point we could actually say it's an equilateral triangle. But I'm going to move on to actually check the angles as well and make they're all pi over 3. So it's going to be one way or the other. This is way number 1, showing that they're all the same length. Now let's look at the angles and show that the angles are all pi over 3. Okay, so we'll start by looking at angle alpha, beta, gamma. Okay, so that's alpha, beta, gamma. That's this angle up here. And I can just use simple trigonometry to work out this angle here. And that's going to be the cos inverse of the adjacent to that angle, which is going to be root 3. So we're looking at this side here, root 3, divided by the length of the hypotenuse here, which we found is 2 root 3. Now there's also another way of doing it, just in case we're not sure that our length 2 root 3 is correct. So I definitely know that this is going to be root 3, and I definitely know that this is 3. So I can do tan inverse instead, if you're not sure that your 2 root 3 hypotenuse is correct. So that's going to be the opposite 3 divided by the adjacent, which is root 3. So I'll work that out and we get pi over 3. It'd be the same as if we had done cos or even sine. You could use any of the trig. Right, now by symmetry again, there is another angle that's the same. So by symmetry, this angle down here, beta alpha gamma, is the same. So write that down. So by symmetry, angle beta alpha gamma is also equal to pi over 3. So by angles in a triangle, the other one must be pi over 3. Angles in and I'll just do a triangle there. The other angle, which is angle beta gamma alpha, is equal to pi over 3. Okay, so that means all angles equal. All angles equal. And then for both of these, my conclusion would be that therefore it's an equilateral triangle. So it's equilateral. And I'll just finish off the conclusion for the other one here. Okay, that it's an equilateral triangle. So either way, I guess you can use to prove that you have the vertices of an equilateral triangle there. Length of sides all being equal, or all angles being equal. Question 6. Part A. Prove by induction that for all n in the set of positive integers that this function f of n is equal to n to the power 5 plus 4n is divisible by 5. So in any proof by induction, we start with our basis step and we want to prove that this is true for n equals 1. So we substitute 1 into f of n and we'll get 1. F of 1 is equal to 1 to the power 5 plus 4 times 1. Well, that's 1 plus 4 is equal to 5, which is divisible by 5. So the statement is true for n equals 1. Okay, so now we come on to our assumption and we're going to assume that the statement is true for n equals k. Right, so that means we're going to write down that f of k is equal to k to the power 5 plus 4k. Step number 3 is our inductive step. Let's get rid of that line there. And this is where we see what we get for n is equal to k plus 1. So that would be f of k plus 1. And that will be k plus 1 to the power 5 plus 4k plus 1. Right, so I need to expand this. So I'm going to do it very quickly. I'm going to use Pascal's triangle. I'm not going to use NCR. It's not worth it when actually we can do this very quickly. And I've already got the coefficients here. 1, 5, 10, 10, 5, 1. And so what I will get for f of k plus 1, that's going to equal to k to the power 5 plus 5k to the power 4 plus 10k cubed plus 10k squared plus 5k plus 1 and then plus 4 lots of k plus 1, so that's 4k plus 4. Now what I'm looking for is somehow to see if I can find f of k or f of a multiple of f of k in here. Now f of k is k to the power 5 plus 4, and here I have k to the power 5 plus 4k. So that means I can write f of k plus 1 equal to f of k plus 5k to the power 4 plus 10k cubed plus 10k squared plus 5k, and then the 1 plus 4 makes 5. Now that means actually what I've got is f of k plus 1 is equal to f of k plus, well, I've got a multiple of 5 here, haven't I? And it's going to be 5 lots of k to the power 4. What's k to the power 4? Plus 2k cubed plus another 2k squared plus k plus 1. So now we can write our statement, which is the statement is true for n equal to k plus 1. So since this statement was true for n equals 1, so since true for n equals 1 and assumed true for n equals k, that means that it follows that it's true for n equals k plus 1. Therefore, by mathematical induction, we want to really have that statement in there. Mathematical induction, we can say that the statement is true for all n, or all these positive values of n. The statement is true for, and we want to say the same as what was given in the question, n in the set of these positive integers. Okay, let's move on to part B, and it says here that we need to show that f of negative x is equal to negative f of x for all x in the set of real numbers. That would mean actually that this is an odd function. So let's go about this proof. So f of negative x is going to equal, well, we'll just put negative x into our function, so that'd be negative x to the power 5 minus 4 times by negative x. So that will give us negative x to the power 5 minus 4x. And we want a plus here, so it's plus 4, plus 4 there. Okay, so that's what we get for negative x. Right, okay, let's see what we get for positive x. So f of x, and we're actually now working out negative f of x. I don't want to miss that out. So negative f of x will basically be just a negative sign in front of the whole thing. So negative x to the power 5 plus 4x, and that will just be negative x to the power 5 minus 4x. Now I can see that these two statements are the same thing, aren't they? Negative x to the power 5 minus 4x, negative x to the power 5 is equal to minus 4x. So I can just say, therefore, f of negative x is equal to f of x. Part C, and it says, hence prove that f of n is divisible by 5 for all n in the set of positive and negative integers. So basically, we need to show that the statement is true for positive integers, for negative integers, and for 0. So first of all, in part A, we proved that f of n is true for all positive integers, so we can tick that off the list. Let's see if we can prove this statement is true for 0. So f of 0 is going to equal 0 to the power 5 plus 4 times 0, which is 0, and 0 is divisible by 5. It is divisible by 5. 0 is divisible by everything. So we've proved it's true for 0. Now, since we've already proved that f of n is divisible by 5 in part A, negative f of n is also divisible by 5, because all we're doing is looking at the negative numbers, so they're always going to be also going to be divisible by 5. So f of negative n is also divisible by 5 because of what we proved in part B. That is that negative f of n, negative f of x is equal to f of negative x. Therefore, f of n is divisible by 5 for all negative integers. So we've proved the last bit. So we've proved it's true for positive integers, 0, and negative integers. So we can say now, therefore, f of n is divisible by 5 for all the integers, positive ones, negative ones, and 0. Question number 7. The population of zebu cattle in a particular country is modelled by two subpopulations, adults and juveniles. In this model, the only factors affecting the population of the zebu are the birth and survival rates of the population. Data recorded in the years preceding 2018 was used to suggest the annual birth and survival rates of the population. The results are shown in the table below with values to two significant figures. It is assumed that these rates will remain the same for future years. So we've got a birth rate, survival rate of the adult population and the juvenile population. It is assumed that 1/3 of the surviving juvenile population become adults each year. A sub j and J sub n be the respective subpopulation in millions of adults and juveniles, n years after the 1st of January 2018. Then the adult population in year n+1 satisfies this equation here. A sub n plus 1 is equal to 0.97 an plus 1/3 times by 0.87 jn is equal to 0.97 an plus 0.29 jn. Part A. From the corresponding equation, I'll form the corresponding equation for the juvenile population in year n+1 under this model, justifying your values. Okay, so we need to look at how this juvenile population is formed. Well, you're going to get juveniles that are born, okay, and that's going to be 0.23 of the adult population in the previous year. So this bit here represents newborn juveniles. Newborn juveniles, or little kids. Then you've got existing juveniles. Now it says that 1/3 of the surviving juveniles become adults each year. That means that 2/3 of them don't. And that's going to be 2/3 of the surviving juveniles. So that's going to be 2/3 of 0.87 jn. So this part here represents the surviving juveniles that were there already. So what that will give me is jn+1 is equal to 0.23 an, and then if I work out 2/3 of 0.87, I'll get 0.58 jn. So that's going to be the equation that represents how I work out the number of juveniles in the next year from the juveniles and adults in the previous year. Okay, the total population on the 1st of January 2018 was estimated to two significant figures as 1.5 million zebu, with 1.2 million of these being adults. Part B, find the value of P and the matrix M such that the population of zebu can be modelled by this system. A0J0 is equal to 1.2p and an+1 jn+1 is equal to this matrix M times by anjn. And we need to give the value of P to two significant figures and each entry of M to two decimal places. So let's start with the first matrix, which is basically going to be the initial number of adults and juveniles, and we're told that there are 1.5 million of them. 1.2 million are adults, so that means that the remaining are juveniles, and that's going to be 0.3, because basically all I've done is 1.5 million minus the 1.2 to give me 0.3. So that gives me my value of P as 0.3. So that's going to be the first part of my answer. Then I need to form this second matrix here. Now I've already I worked out in part A the equation for the juveniles, and we were given in part A the equation for the adults, and that was A sub n plus 1, the adults in next year, is 0.97 an plus 0.29 jn juveniles. So this is what I'm going to be using as well. I basically just need to put that in matrix form. So let's do that. So A sub n plus 1, J sub n plus 1 is going to be equal to, now what I'm going to have is the adults and the juveniles here, and I just need to put in the correct coefficient so that I form these two equations. So an, that's going to be 0.97, and then I'm going to have 0.29 because I want 0.29 in front of the juveniles, so that's going to give me this equation here. And then for this one it will be 0.23 and then plus 0.58. So you can see all I've done is just take the coefficients from those two equations. So that forms my matrix M here. Now I did notice it did say that we need to give P to two significant figures. I know it's 0.3. I guess if I'm going to be strict about it, it should be 0.30. And yeah, this is my matrix M. Right. Use the model formed in part B, which is what we've got here, to find to three significant figures. The first part of part C is the total zebu population that was present on the 1st of January 2015, and then in the second part the predicted juvenile zebu population on the 1st of January 2025. So I need to find for the first part of part C, like the previous population to the 1st of January 2018. So I basically want to find AN and JN, seeing that I know AN plus 1 and JN plus 1. So if I write that out as an equation, so I know like the next year 1.2, 0.3, I want to find the previous year. I guess this is like finding A negative 1 and J negative 1. So using basically this equation here, I'll have the 0.97, 0.29, 0.23, 0.58 AN, JN, and I know that if I'm going to solve this, I need to multiply both sides by the inverse of M on the left, like that. So I'm going to find the inverse matrix. Now this we do on our calculator, and if I do that, I'll write down the values that I get. If you hover over the elements, it will give you the fractional answers which I want to use. Some of these fractions are a little bit on the big side, but I want to be as exact as possible, so I'm just writing them down now. So this is the inverse of that matrix M, and the last one here, I guess it can't give that value exact, so the 1.95603, and it carries on. Okay, so there's my inverse matrix. So ANJN is going to be equal to that inverse matrix, I'm not going to write it out again, times by 1.2, 0.3, and that can be done on my calculator, and that will give me AN is equal to 1.22807 and so on, and JN, remember this is in millions, 0.03024. The first part of part C is asking for the total population, so that total is going to be the ANs plus the JNs, the adults plus the juveniles, so 1.228 so on, plus the 0.030, and that gives me 1.258 it's asking for the answer to 3 significant figures. So that's going to be 1.26. Now remember, that's million. Zebu. Okay, so let's just highlight that. Now for the second part of part C, it's asking about January 2025. So that's 7 years after 2018. So we want to find A7, J7, and that's going to be equal to, now that'll be this matrix M here times by itself 7 times, so to the power of 7, and then that gets times by this 1.2 and 0.3 initial population. Again, this is something we do on our calculator. So the number of adults is like 2.1173, and the number of juveniles in this 7th year 2025, so J sub 7 is going to be 0.9381 and so on. And we just need the number of juveniles, so that's this number in terms of millions, and again 3 significant figures, so we can write that as 0.938 million, or you could write it as 938,000 as the number of juveniles. Right, let's continue. As a result of the predictions of this model, it is now decided that the country will export 15,000 juveniles to a neighbouring country at the end of each year. Part D, adapt the model from 2018 onwards to include this export. Now, a model needs to include the initial values, the initial population, so the model will still have A0 and J0 as this initial population of 1.2 and 0.3. That's part of our model, but we do need to adapt what we have here. So we're still going to be working out the number of adults and juveniles using the previous populations, but we do need to show that the population of juveniles is going to be reduced by this 15,000 juveniles per year. And the way that we can do that is to say, okay, this is my existing model, let's just subtract no adults but 15,000 juveniles. Now we need to remember this is in millions, and 15,000 in millions is going to be 0.015. So we need to be subtracting here 0.015, and we need to show, well, this model is from 0, 1, 2, 3 and so on. And then part E, state one limitation of the models. Well, there are several limitations, and I'll write them down and then we'll go through them one by one. We probably only need one of these. So you can talk about the birth or death rates not being constant. The zebu may be lost in other ways, e.g. they may be lost by disease or hunting, etc. Or we could talk about those being removed, they may actually affect the existing population. Question 8. Figure 1 shows a sketch of the curve with equation y is equal to x to the power 2/3. The curve passes through the point A with x coordinate 8. The region R1 is bounded by the curve, the vertical line passing through A and the x-axis. The region R2 is bounded by the curve, the horizontal line passing through A and the y-axis. The solid V1 is formed by rotating the region R1 through 360 degrees about the x-axis. So let's draw on what that's going to look like. So this shape here is going to get rotated 360 degrees around the x-axis here. So I'm going to have a sort of 3-dimensional shape that's going to look something like this. Yeah, that's my attempt at drawing a 3D shape. And the solid V2 is formed by rotating the region R2 through 360 degrees around the y-axis. So that's going to be a rotation around this way. And again, my attempt at trying to draw out what this 3D shape will look like. So I guess something like this, some sort of horn type shape, like that, or cone, curved cone. Part A, show that the exact volume of the solid V1 is 384 pi over 7. So first of all, let's just remind ourselves of the volumes of revolution. So I'll color code this. So volume of a revolution around the x-axis is going to be pi, and we will have limits of x1 and x2, I could call them alpha and beta, y squared dx, and then volume of revolution around the y-axis, that volume is going to have y limits, y1 and y2, and this will be x squared dx. So let's start first of all trying to calculate the volume V1, which is generated by rotating the region R1 around the x-axis. Right, so that will be equal to pi times by, and my x limits are going to be 0 and 8, they're the two ends of the shape, and then y, well, that is x to the power 2/3, that's going to be squared dx, so that will be pi times by the integral between 0 and 8. So if we square x to the power 2/3, we get x to the power 4/3 dx, and so we'll have pi times by, so if we integrate x to the power 4/3, we'll get 3/4 x to the power 7/3 between my limits of 0 and 8. So we'll substitute in the 0 and the 8, so pi times by, and so we'll have 3/7 times by 8 to the power 7/3, and then minus 3/7 times by 0 to the power 7/3. So that will give me pi times by 384/7. So we'll get that volume V1 is equal to 384 pi over 7 as required. Okay, the solids V1 and V2 are placed in an empty container. A solid is selected at random and then replaced in the counter. This is carried out 10 times. Given that the probability of selecting each type of solid is proportional to its volume, Part B, find to 4 decimal places the probability that the solid V2 is selected exactly 8 times. Okay, so the first thing we need to do is to find the volume of this solid V2. Now, before we do that, I need to know the limits. I know this lower limit is 0. I know the x coordinate here. I'm going to use that x coordinate and the equation to work out the upper y limit. So upper limit, we need to do that first. That's going to be equal to, or the way we'll get that, y is going to be 8 to the power 2/3, just using the original equation here, and that will give us 4. So that now gives me my upper limit for the volume V2. So this is going to be pi times by the integral between the limits of 0 and 4. And remember, this time we now need to do x squared. So what I need to do, first of all, is to take this equation and make x the subject. So if I do to the power 3/2 to both sides, like this, so x to the 2/3 to the power 3/2, well, that will give me x is equal to y to the power 3/2. So it's going to be y is 3/2, or to the power 3/2, and that's going to be squared, and this is dy. So from that I'm going to get pi times by this limits of 4 and 0. So y to the power 3 over 2 squared becomes y cubed dy. That's easy enough to integrate. So I'll get pi times by a quarter y to the power 4 between these limits of 0 and 4. So that's going to be pi times by, and let's put these in, so it'll be a quarter times by 4 to the power 4 minus a quarter times by 0 to the power 4, and that gives me 64 pi. So that's the volume of V2. So now I'm going to work out the probability of picking the shape that has volume V2, and that's going to be the volume of V2 divided by the total volume of the shapes that are in this bag, and that's going to be 384 pi over 7 plus 64 pi, and that gives me exactly 7 over 13. So there's my probability of success. Now if we look at the question, we have 10 trials, and we want to find out that the probability that a solid is V2 is selected exactly 8 times. So this is a binomial distribution where we have 10 trials, and the probability of getting V2 is going to be 7 over 13. And I need to work out the probability that I'm successful exactly 8 times. So this can be done on my calculator, and I'll get 0.0677743, and it carries on. And we'll give that to 4 decimal places as arcs, so that'd be 0.0677. So that will be the probability that I pick volume number 2 exactly 8 times if I have 10 trials. Question number 9. A small comet C is passing near to a planet. The planet can be modelled as a sphere with centre O taken as a fixed point in space, so that the motion of the comet is relative to the origin O. The diameter of the planet is 13,000 kilometers. The comet is monitored by satellites orbiting the planet. When the monitoring begins, the comet is at position 146i plus 234j minus 85k and is moving with vector negative 21i minus 33j plus 13k every hour, where the units are in thousands of kilometers. Assuming the comet maintains a straight line course throughout its motion, part A, determine whether or not the comet will collide with the planet. Right, so here I've got the diameter of the planet is 13,000. This is measured in thousands of kilometers, so this is going to be 13 here. That's the number I'm going to be using. And then when monitoring is beginning, I have the initial position of the comet plus how it's moving, so that's basically its direction. So what we have is the center of the planet as the origin. So imagine that the planet is going like this, okay, and then this distance here is going to be the radius, that's going to be 6.5, and we want to know how close is the comet going to pass the planet. So is this distance here more or less than 6.5? So we need to start first of all by looking at the path of the comet and model this as a vector line. So we'll want its direction first, and its direction is negative 21, negative 33, 13. From that we can write the vector of the path of the comet. So that's going to be its initial position, so 1, 4, 6, 2, 3, 4, negative 85, plus its direction, and we'll put a scalar there, negative 21, negative 33, 13. I'll combine that all into one bracket, so I'll have 146 minus 21 lambda, 234 minus 33 lambda, and negative 85 plus 13 lambda. Now I'm going to use this, it's basically a general point on line, to find this perpendicular vector here, this normal. So I want to do the dot product of this with the direction of the comet. So that's going to be 146 minus 21 lambda. So basically the same thing that I've had before, and as I said, I want to do the dot product of that and the direction of the vector, negative 21, negative 33, 13 is equal to 0. So if I do the dot product, I'll get negative 3066 plus 441 lambda minus 7722 plus 1089 lambda minus 1155 plus 169 lambda is equal to 0. So I can simplify all of that and get 1699 lambda is equal to 11,893, and that will give me lambda is equal to 7. So this lambda equal to 7 is going to give me this vector here, and I want to find the length of that. So when lambda is equal to 7, and that will give me the vector, so I'm going to substitute 7 into here. I get negative 1, 3, 6. And what I want to do is to find the length of that, the size of that. That will tell me how long this vector is here. So I'll just do Pythagoras on it. Let's do it right over here. I've got a bit more space. So that would be the square root of negative 1 squared plus 3 squared plus 6 squared. That works out to be the square root of 46. Oops, not sure what's going on here. 46. And that gives me 6.7823 and so on. Now that is greater than 6.5, isn't it? So since the square root of 46 is greater than 6.5, the comet will not hit the planet. The comet will not hit the planet. Two of the satellites, A and B, have position vectors OA 5i plus 12k and OB 4i plus 12j minus 3k. At the beginning of monitoring, they return to these positions every 4 hours. Part B, find the expected angle ACB between the comet and the satellites A and B when they first return to their initial positions. Give your answer to the nearest 1/10 of a degree. So let's draw out what this looks like so I can physically see what's going on. So I have these points here, all these satellites A and B, and I have their positions. So I've got 5, 0, 12 here for A, and B 4, 12, negative 3, and the comet, and that's going to be at the time 4 hours, so that's going to be when lambda equals 4 at this point C, the comet. So that's the first thing we need to do, is to work out what that position is. So we'll take our comet position here and just substitute lambda equals to 4, because that's going to be the first time that they return to their monitoring position. So I'll have 146 minus 21 times lambda, which is 4, 234 minus 33 times by 4, and then negative 85 plus 13 times by 4. Working that all out, I'll get 62, 102, negative 33. So I can put that down now as this position here of the comet. 62, this is going to be its position after 4 hours. 102 minus 33. So I want to find the angle here between these two satellites here in a comet. So the vectors need to be pointing away from there. So I need the vectors CA and the vector CB. And I'll be using the cosine of the angle is equal to A dot B over the length of A times by the length of B. So let's start by looking at the vector CA. So I would do 5, 0, 12 minus 62, 102 minus 33, and that gives me negative 57, negative 102 and 45, and then also the vector CB, and that will be 4, 12 minus 3. Remember, you do the second vector minus the first, or you can work out a jump between the two. Minus 62, 102, negative 33. I'm working all of that out. That gives me negative 58, negative 90, negative 30. So the cosine of the angle is going to be the dot product of those two vectors, negative 57, negative 102, 45, dotted with negative 58, negative 90, negative 30, and that's all going to be divided by the length of the vectors. So a couple of big square roots here, and that's going to be 57 squared plus 102 squared plus 45 squared here, times by 58 squared plus 90 squared plus 30 squared. Doing all of that on my calculator, I'll get 13,836 at the top, and that's divided by the square root of 15,678 times by the square root of 12,364. Let's tidy up this line here. Right, so doing the cos inverse of that, I'll get theta is equal to 6.3991 and so on. It does say give the answer to the nearest tenth of a degree, so I'll have theta is equal to 6.4 degrees. And then finally part C, give a reason why the answer to part B may be different from the true value. And really, we can just state that the path of the comet may not necessarily be a straight line. If you know anything about astronomy, when comets pass by stars or planets, they're affected by the gravitational pull of that star or planet, and it actually curves their path. So that would be my main reason for saying why my actual answer for part B would differ from the actual true value, because of the path of the comet not being exactly a straight line. It's affected by gravitational pull.